I would like to thank everyone again for being here with us today. So today I'll be sharing with you some of our findings from our IAQ market and technology landscape study with a focus on materials for better indoor air quality. So this is what I'll be running through with you today. So for the creation of a comfortable, healthy and indoor environment for us to live, work and play in, the different sectors that we see here, of course, for the IAQ market would be the residential, commercial, industrial, as well as the transport sector. So across these different segments, there are some common IAQ pollutants across them. But of course, because of certain operation requirements that are in different sectors, there are also very sector-specific requirements. So for example, in the vehicles, fine particles, as well as gaseous pollutants such as NOx or SO2, this would actually be the more critical indoor air pollutants for us to look into. So in our study here, we have actually focused more on the residential and commercial market segments. But I also like to keep everyone in mind that actually the IAQ solutions developed or implemented in one sector, they may also have the potential to be cross-applied in another. So a quick view of the IAQ market outlook. The global IAQ market solutions here that covers both products and services is expected to grow by 9.5 billion by 2024. And the US market is also expected to grow and reach 12.2 billion by 2023. But the fastest one is actually going to be expected in APAC for the fastest growth, with about 33% expected to come from this region. So, but do note that these numbers actually came from reports published pre-COVID-19. So as the market conditions are impacted by the pandemic and the constant evolving situation, these numbers will likely change. But considering the relevance of IAQ in this current situation, we do believe that there are still growth opportunities in this market. So we'll take a look at some of the main market drivers that can contribute to the growth of the IAQ market. So firstly, declining indoor air quality. We feel that we see now the IAQ level is declining faster than the implementation of strategies and adoption of air cleaning solutions. This also corresponds with declining outdoor air quality, due to urbanization and changing human consumption patterns. The impact of IAQ on health and well-being as well significantly drives consumer demand, not only for the residential air cleaning solutions, but also the demand for healthier commercial spaces. And closely related to this, the drive towards green, healthy buildings. So besides the intent of preserving the natural resources and lowering energy usage, another key objective of green buildings is actually also to improve the health and well-being of building occupants. So take a closer look at each of these market drivers here. Regular indoor activities such as even cleaning and cooking actually generates indoor air pollutants as well. So with many of us still working from home, with these activities increasing significantly, this also in turn the generation of indoor air pollutants. So to address this, ventilation is of course important, and venting our homes, in a tropical country like Singapore is rather straightforward. But then in commercial buildings that are built to be airtight, it actually can be a double-edged sword. Because while we can reduce the infiltration of outdoor air pollutants, there may also be a buildup of indoor generated pollutants if the ventilation strategy is not so appropriate. Depending on the outdoor air quality, ventilation can also introduce even indoor air pollutants. Studies have actually shown the strong correlation of IAQ with outdoor air quality. Although there were earlier reports of better air quality in recent months as countries were under lockdown, that situation may not really last as we resume our economic activities. So IAQ, of course, is not a new subject and has been studied really for decades. There are also actually more studies now conducted to actually prove the health impact of IAQ, resulting in actually a growing awareness in this area. So here in this chart here, we see some results from a Harvard University study. They actually found that when the CO2 levels were lower, simulating green building conditions, building occupants actually scored significantly higher in their cognitive functions such as crisis response, strategy, as well as information usage. In recent years, there is also an increasing usage of IAQ monitors, which also plays a part in augmenting actually the occupants' awareness of the importance of IAQ. The pandemic has also amplified actually the observation that consumers are becoming increasingly aware, or we could also say conscious, of the importance of the safety aspect of indoor air, because we know that indoor spaces do pose a higher risk in the spread of airborne diseases as compared to outdoor ones. The drive towards green buildings have started some time ago, and we do not think that it's slowing down. A green building report actually also showed that environmental regulations is actually a key trigger for green building in several countries, including Singapore. So over here, we have actually building regulations and plans that are in place so that new buildings as well as existing buildings that undergo major retrofitting are actually to meet our minimum BCA Green Mark standards. So although not all countries have incorporated IAQ requirements in their building codes, countries such as Japan, South Korea, Vietnam, as well as Thailand, they do have some mandatory requirements. So besides environmental regulations, another top trigger is actually about healthier buildings. In general, also, the pandemic has actually forced us to address this issue and may actually further spur the trend of healthy buildings. But of course, the IAQ market is not without its challenges. So firstly, indoor air pollution itself is actually quite a complex challenge. So there are multiple pollutants that come from different sources, and each of them requiring different strategies to tackle. It's also influenced by factors such as temperature, humidity, and even poorly maintained air purifying systems could also become a source of pollutants. IAQ monitoring also plays a very important role nowadays. While there are multiple sensors that can detect and measure, say, PM 2.5, CO2, and humidity, not all air pollutants are actually as detectable. So for example, for biological contaminants, different tests are still actually required in order to identify them. Increased ventilation will lead to increased energy loads, of course. And with the ACMV systems contributing about 40 to 50% of the building's energy costs, and also keeping in mind that pressure drop from the use of air filters can also impact energy efficiency, the balance here is actually important. And also, despite the known risks of poor IAQ, the related costs are actually still a key determinant in its implementation. So determining the overall business case can be quite complicated when the benefits of IAQ are not always immediately apparent, and also when costs are actually borne by different parties. So nevertheless, we do think that there are still certain gaps and opportunities to address these market challenges as well as the market drivers. So for example, end users can consider designing in IAQ at earlier stages as a form of preventive measure. So instead of spending additional resources later on to resolve certain issues, which can actually be more costly at times. And with the pandemic as well, it's definitely pushing for more action to make our indoor spaces as safe as possible. And also such improvements may no longer be considered as optional now in the new norm. Energy efficiency, of course, being a key component, is also important for IAQ solutions to really be low or zero energy consumption if possible. And to a complex IAQ issue, simpler and multifunctional solutions can be a desirable response. And when trying to improve IAQ, the main strategies adopted are often based on controlling the source or the ventilation, but further enhancements may be required. So this could be through additional air cleaning measures or dynamic systems that can actually better respond to changing conditions. So with that, we'll now take a closer look at these three key strategies currently being used to improve IAQ. So first, take a look at source control, which is basically the elimination of individual sources of pollutants or reducing their emissions. So in this table, we can see some of the indoor air pollutants as well as their main sources. So source control is generally considered as the more economical and effective strategy. So for example, VOCs like formaldehyde, they are known to be emitted from furnishings and decoratives like paints, wooden furniture. But there has been already a lot of development in this area to produce low or no VOC green building materials. And if these are replaced, the amount of VOC pollutants in the environment can be significantly reduced. But it is also unlikely for us to actually be able to remove pollutants completely. Using this same example, green building materials, they also typically come at higher costs. which can continue to be actually deterring more price-sensitive consumers and businesses. And in some cases, it could even simply be not really within our control. So for example, outdoor air quality or pollutants are actually generated as, as a result of occupancy. And also during this current pandemic, where we're doing more cleaning, using more disinfectant products, which are often aerosols or alcohol-based, these actually also contribute as a source of indoor air pollutants. So next we look at ventilation, which is really an essential and proven strategy. Studies have shown the health and well-being benefits of ventilation. And in times of the pandemic now, it is also a very fundamental strategy that is being recommended by experts. But achieving good ventilation control, particularly in commercial spaces, is really not an easy task. Here, getting the airflow optimized for effective ventilation can sometimes be quite challenging because the actual airflow in real occupied spaces often deviate from modeled scenarios because internal spaces can be modified, say, by furnishings or by additional partitions, etc. Ventilation controls have definitely become more advanced now, enabling more timely as well as energy efficient ventilation that actually can respond to demand. But adding such controls to existing systems can also be challenging if you look at the higher costs associated with the installation and maintenance of the multiple sensors, as well as integration with the building management systems. Air cleaning involves the passing of air pollutants through a system for the removal, destruction, or transformation of air pollutants. So it should be noted here that, of course, the effectiveness of air cleaning will be reliant on the airflow rate as well as the operating time of such systems. Air cleaning is also proven actually to be a strong complement to source control and ventilation. And we know there is a variety of air cleaning technologies out there in the market. And we frequently see a combination of different technologies because each one of them actually tackles different types of pollutants. So here's a quick comparison of the various air cleaning technologies available in the market. We can classify air cleaning technologies into two broad classes. Firstly, materials-based. We're looking at the filters, catalysts, biological materials, or ozone. There are also electronic methods, including plasma, ionizers, electrostatic precipitation, etc. They compare in terms of the types of pollutants being removed by each type of air cleaning technology. Of course, we see here materials-based technologies, they actually can target more than a single class of pollutants. If you see in this table here, they are actually able to tackle about 2 of them at least. Whereas on the other hand, for electronic methods, they tend to focus on a single class of pollutants. So here we see another view of the type of pollutants being removed by the different air cleaning technologies. So generally here we see here how air cleaning materials are more versatile in targeting the different types of pollutants. So now in terms of the mechanism of action, which is how the air cleaning technology actually works in removing the pollutants, in terms of the working principle, one of them is by collection. So that is really they are collecting and trapping the air pollutants. Say for example, for the fibrous filter media, that's how it works in terms of trapping dust particles. There's also some that actually convert the air pollutants into something else. So for example, catalysts used in the catalytic oxidation processes, they actually can convert, say for example, formaldehyde into CO2 and water through a chemical reaction. Others destroy the air pollutants. So for example, there are some biological materials that can actually kill the harmful microorganisms. But of course, each air cleaning technology also comes with their own pros and cons. And in general, a lot of the air cleaning technologies have high theoretical efficiencies as the key advantage. So I want to really point out here is theoretical efficiency because as we all know, how the air cleaning technology is being designed to the system, how it's being deployed, and how it's being maintained can still affect its performance level. And in terms of these advantages, energy consumption as well as the generation of harmful byproducts such as ozone or other chemicals, they are actually some of the most common disadvantages found in quite a few of the existing air cleaning technologies. So in summary, there are a number of different technologies and solutions available in the market, but there really isn't a one-size-fits-all. And with the use of materials or technologies with broad spectrum effectiveness, we could actually minimize possibly the number of combinations needed. And such multifunctional technologies also actually, which work on its own passively, could also improve energy efficiency. So with that in mind, we'll now zoom in and take a closer look at the innovation landscape of filtration, catalytic oxidation, and biological methods. So by making use of a patent landscape study, we can actually gather some insights into the innovation activities surrounding the development of these different technologies. So first, we'll take a look at the patent application trend. So for filtration, it is by itself a mature and stable market. So we are actually observing as well a similar trend here in terms of patent filing. Catalytic oxidation, it is a rather established technology, but we are still seeing quite a lot of development here in terms of for different applications, as we see it gaining traction as well in the IAQ market. So we are seeing a similar trend here as well. So this increase actually also could be due to the fast growth in the number of Chinese patents around this period of time. And for biological air cleaning methods, it's still an emerging area with a lower number of patent applications. But with increasing interest in natural and in sustainable solutions, this area is expected to continue to grow. So in terms of who are following these patents, we actually see Chinese organizations leading in this area, and there's a particularly strong focus in terms of catalytic oxidation as well as biological methods for air cleaning. On the other hand, US organizations, they dominate in terms of filtration technology. And European as well as other Asian organizations from Japan, South Korea, as well as Southeast Asia, the focus is more on catalytic oxidation as well as filtration technologies. We also analyze the kind of inventions being described in these patents. So majority actually focused on the development of air cleaning systems, particularly those that actually look into the integration of catalytic oxidation. Other patents then describe the components that are being used in such air cleaning systems. So for example, in terms of materials composition that use either biological or catalytic oxidation materials. There's also a portion looking into filter development. So where this organization, they'll be looking at fiber materials as well as composition, surface treatment of the filter media, as well as filter assembly design. So we'll now take a look as well at some of the insights that we have from each of this technology. So filtration being a mature market, it was actually observed that the patents here are mainly filed by commercial entities rather than research or academic institutions. Innovations here are considered as incremental because they are focused really more on improving the performance or the energy efficiency of existing filter technologies. Nevertheless, there are still some development trends that we have observed. So for example, the continued development of nanofibrous filters. So one example here is from Lime Inc. This is from a South Korean company with their nanofiber technology. These 3D networks here can actually further increase the deposit as well as the absorption areas for fine particles. There's also some work done in terms of fixation of functional particles on the fibers to obtain multifunctional filters. So such particles could be absorbent materials or metal organic frameworks. So one example here is from Air Labs. It's a UK startup, and they have a composite filter for different gaseous chemicals. In terms of redesigning a filter's physical configuration, the most common is in the optimization of its shape, so such as adding conical or spherical structures to actually increase the contact time between the polluted air stream and the filter media. As catalytic oxidation is gaining traction in terms of the actual product applications, there is actually interest in both commercial as well as research organizations. We see these also as incremental innovations, mostly looking at enhancing its performance efficiency, but we actually also have observed a shift away from UV-based photocatalysts. So meaning a development of catalysts and materials so that the reactions can actually happen in the absence of light. This can actually translate possibly to more energy efficient as well as less costly systems. The development trend observed revolve around two areas. So there's quite a bit of work in terms of the product development for the module as well as the system designs. So one example here is from Molecule. This is a US startup that has developed their proprietary photoelectrochemical oxidation technology that can remove both VOCs as well as microorganisms. There's also increased development of next generation catalysts. So next generation TiO2 catalysts, as well as those that are based on noble metals or transition metal oxides catalysts, such as this one here from the Korea Institute of Science and Technology. They have developed a low temperature, light-free manganese titanium catalyst meant for VOC oxidation. Biological air cleaning is really still an emerging area. So the innovation landscape is still rather fragmented and there isn't really a leading player. So with the use of plants, plant extracts, bacteria, and as well as enzymes as the core air purification materials, biological air cleaning has strong characteristics of sustainability, such as in terms of its non-toxicity, environmental friendliness, as well as the ability to purify air without secondary pollution. So these are actually some of the key advantages of a biological-based solution. And even though some of the methods here focus mainly on the removal of VOCs, there are also solutions that actually demonstrate the potential for tackling biological contaminants. So in terms of the development trends observed, there are organizations that are actually looking at airflow improvement for those systems that are based on plants. So this is really to maximize the contact between the polluted airstream as well as the plant's root systems where the air cleaning is actually happening. So for example, Tthe is actually an Italian startup that is working on such a system. So there are also systems and compositions that are based on materials using, for example, lactic acid bacteria or protease enzymes. So these rely on the biochemical reactions to metabolize pollutants. Here is an example from China's Harbin Institute of Technology. They're utilizing microorganisms for a low energy indoor air purification system that's actually based on both biochemical as well as electrochemical processes. So we'll now take a look at actually what are some of the technology offers available that provide us with new possibilities when incorporated into IAQ solutions. So one example here to explore would be the air handling unit for an ACM-based system. This is an example configuration for illustration purposes. So for example, there's potential to explore the application of a biofilm coating based on odorless microorganisms on the cooling coil. So this biofilm can prevent the inhabitation of other odor-generating or pathogenic microorganisms. Another example, enhanced air filters with catalysts may be used to remove VOCs, for example, those that are accumulated in recirculating air. Nanofibrous filters could also enhance particle collection efficiency here. So instead of using separate filters for different pollutants, multifunctional filters like this may actually help in reducing the overall pressure drop, hence help in energy efficiency. There are also available technology offers with potential applications suitable for our indoor environment, be it for residential or for commercial space. So for example, the nanofibrous filter that you saw in earlier slide, it could also be produced in such a way to become window filters. So this could be beneficial in certain regions where outdoor air pollution is actually more severe. Nanofibrous filters that are functionalized with other properties can also be used here for the smaller air purification systems. So our next speaker from EWT-COI will be sharing more on their development in this area. Another example here, similarly, the biofilm coating that you saw on the previous slide could also possibly be incorporated into another product format, for example, an air conditioning unit. Alternatively, we could look into antimicrobial coatings that can be applied on high-touch surfaces, which could also provide some support in purification of the surrounding air. So such coatings may also find applications in air filters, for example, serving to minimize the growth of microorganisms on these filters. So you'll hear more about antimicrobial technology later from our guest speaker from Polymer Materials. There's also development of air purifying systems actually based on microalgae, which may be installed to actually remove CO2. So they are absorbing and converting CO2 into oxygen. Reduction in indoor CO2 is actually associated also with a reduction in energy used for ventilation and cooling. So another example here using a photosynthetic algae system. This company is actually using microfluidic technology to improve the efficiency of their photobioreactor. So finally, we'll take a look at some of actually what are the potential adjacent markets. So technologies designed for IAQ market can also have some cross-industry applications that provides us with opportunities to explore in others as well. So for example, in cold chain, logistics, refrigeration, as well as agriculture, these applications involve enclosed spaces as well. So there are also certain environmental parameters such as CO2, oxygen, humidity. All these can actually influence the quality of the products in these spaces. So actually, if you look at IAQ solutions that were designed for the removal of CO2 and VOCs, they could also potentially be modified to suit these different applications. Odor and biological contaminants are actually also present in many other industries. So similarly over here, technologies could be optimized to suit these different applications. So with that, I'll end my presentation today. So for more information about my sharing today, please download our complimentary white paper. You can scan this QR code over here. A detailed market and technology landscape report is also available if you are interested. So if you are keen to explore any of the technology offers that I shared in the earlier slides, opportunities in IAQ or even in other areas, be it to identify technologies, or relevant testing partners, etc., please feel free to contact myself or my other colleagues from IPR after this event. Thank you.